Could Jack have fit on the door with Rose at the end of Titanic? Personally, I think yes, just scoot over a little bit. But in reality, there's a lot more complex stuff that goes into it like that. And the same principle applies to commercial solar design. I know, quite the connection there. But there's a lot that goes into it. Business owners will look at their roof and say, oh, there's tons of space. And then when they finally get a design, it's way less than they think because there's a ton that goes into it. So stay tuned because we're going to go through what goes into commercial solar design and how that design actually happens. As with residential designs, the project always starts with a site visit where teams are going to come out to the building. They're going to walk the property. Of course, they're looking at the electrical system. How are you going to get on the roof? That's a really important question on its own. Can the electrical system actually support solar and how much solar is going into there? And they're also going to look at things like the structural load of the roof. Have to make sure that that roof can not only handle the solar panels going to be on there, but also other elements. Like, do you live somewhere where it snows, for example? That roof is a really big consideration, right? What is the age of that roof? Commercial systems, if they have to replace the roof, it's a lot more expensive than a residential home doing that as well. And one of the big considerations you have to make is how much space are the panels going to take up? Because panels, depending on how you place them actually on a roof, can change quite a bit. To illustrate this a little bit, I brought in a special friend, the mini panel. Now, this is actually a real solar panel, it's just a small one, but when you land panels flat on a roof, you can obviously get more of them close together. But a lot of times, for optimal energy production, you're going to tilt them upward a little bit, actually. So they're actually facing more toward the direct sun. When you do this, that panel casts a shadow back here. So you have to space out the next panel to start back over this way, so it doesn't get shaded by the one next to it. One of the key considerations for commercial solar design is access pathways and the electrical route. There's a lot of different codes that go into it, but when you're planning these systems, it's not just as simple typically as one little conduit that goes down the side like on a home. You have to plan where the inverters are going to go, right? Are they on the roof? Are they on the side of the house? How do the thick conduits actually have to run through to get all that wiring down to the electrical system, which is typically not just as easy as it's sitting on the side of the building. You also have to consider access pathways. When you're getting into really large commercial solar, there's actually codes that require every such distance for there to be a walkway so you can access them more easily, especially for maintenance purposes. Speaking of codes, there's a litany of codes that commercial projects have to go through in order to get approved. Of course, there's local building codes. You have to follow any local jurisdiction requirements. But on the larger scale, you have, of course, the National Electric Code, or NEC. Different jurisdictions have different versions of the NEC adopted, but largely the NEC is going to tell you how conduit has to be run, where its safety disconnects have to be, where even inverter equipment has to be. It's a really overarching policy. You're also going to have fire code setbacks. Anybody who has solar on a residential home knows about fire code setbacks because it's the reason why you can't actually put panels edge to edge on a roof. A fire code on a typical residential building is going to require a 3-foot setback, typically from the top bridge and from the sides. There's a few local jurisdiction differences from that, but generally that's a pretty good rule of thumb. The same kind of thing exists on commercial systems, but because commercial systems, their roof is not just a plain flat roof. There's often HVAC equipment, skylights, there's vents everywhere. The fire code requires a lot more setback. So it's not only from the side of the roof, but also from these other obstructions that are going to be on top of that roof. And one of the largest things that affects commercial solar design is, of course, the utility and their interconnection standards. Sometimes this even supersedes what the building itself can actually hold as capacity because the utility is going to set standards of what can be connected to their grid. 99.9% of all solar is connected to the grid. So the utility in the area, when you go to permit a project, is going to look at the grid stability in the area, or look at the transformers as well, so that they can say, hey, we can actually support only X amount of solar. In a lot of cases, I've even seen on projects I've done where in order to get the large enough product you want, you may have to, as the customer or the business, upgrade the transformer in your area. Sometimes the utility will make you pay for that. It can add thousands of dollars of cost onto a project. All of these together make up the complicated commercial design space. And just like Jack and Rose on the door in Titanic, it's not as simple as it quite seems. And the best thing for solar businesses, or businesses in general who are looking to go solar to do, is work with an expert team who knows what they're doing and can really navigate all the codes. Bonus points if that team is local to your area and has worked in your jurisdiction before. Thanks so much for watching. Check out the rest of our videos on our channel. There's a ton about commercial, residential, solar, and everything in between.